Welcome to chapter 10 of statistics here. And today we're going to deal with another situation. In 9.3, we dealt with dependent match pair data. They shared a link or relationship and they had the same units. Now, sometimes we have data that is quantitative and has two variables. And so we call that bivariate data. And there is a relationship between them, but sometimes they don't have the same units. So we can't use the techniques we learned for dependent means in the last chapter. So we're going to study this guy right here, this linear correlation. And that means that as one variable increases, the other variable either increases, called positive correlation, so they increase together, or that as one increases, the other one decreases, called negative correlation, and they happen at a corresponding fixed rate. Now, there are other correlations, such as quadratic, exponential, or logarithmic, but we're not going to focus on them here. So in our first graph right here, we can see that this has a pattern, and it looks a lot like a line with a upward positive slope. So we would say that this has positive linear correlation. I'm going to pause the video and let you determine what the other three graphs look like here. All right. Hopefully you saw that this is negative linear correlation because it looks like a line but with negative slope. This one here, I can't see any kind of pattern, so we would say that that has no correlation. And this last one, there is a pattern. It looks kind of like a hill or maybe even sort of bell curvy, but it's not a line, and that's what we're going to focus on. So we're just going to, for right now, call this a not linear correlation. Now, we like to measure how strong the correlation is, and to do that, we have got a guy called the linear correlation coefficient, and to talk about him in shorthand so we don't have to use that big long name all the time, we just call him little r. So r is a number from -1 to 1 that tells us how well our data fit on a given line. And let me go ahead and draw a graph down, our little number line right here. So r has to be between -1 and 1, and with 0 in the middle. If r equals 1, that is a perfect positive linear correlation. Oops, let me move that over so you can see it. If r equals -1, we get a perfect negative linear correlation. Okay. And if r is close to 0, then we have basically no correlation. No linear correlation, that is. Okay. And so what does a perfect positive correlation look like? It would look like a line where every single dot is on that line, and the line has positive slope. Perfect negative linear correlation is, again, all the dots lie exactly on a line, but this time the line has downward negative slope. Okay. So what I'd like you to do is go back up here and try to guesstimate what the R value is for this guy, for each of these graphs. And let's do this first one together, and I'm going to try to just maybe draw in what a line would look like. And so those dots are really close, but not perfectly on a line. So I would guess that the positive, or the measure of the linear correlation, would be something very close to, but not exactly a perfect one. And so something close to +1 would be like 0.95. So pause the video and try the other ones. Okay. So on this one, again, we have something very close to a line with downward slope. So I'd guess something about -0.90. This one, where we have no correlation, the R value is going to be really close to 0. It's really hard to get the R value to be exactly 0. But anything close to 0 has no correlation, as we saw down here. Okay. If you want, there's a really cool applet online that I will share with you. It's at the Rossman Chance applet collection, and it's called the Correlation Guessing Game, where you can even track your performance. And so you can have it give you a sample of 25 points, and we can see here that those are really close to a line with negative slope. So I'm going to guess that the correlation would be about negative 0.9, and then you can check your guess. Hey, I was pretty close there. And we can do another sample. Ooh, this one's kind of tough. I'm going to guess that that's about 0.2-ish. Okay, I was sort of in the neighborhood. And the more you practice with this, the better you get. So let's try one more. Randomly generated. I'm going to guess about negative 0.6. Oops. See what we did there. Okay. And if you want, you can track your performance down here and see how close you are, how much error you have. So, but that's just something a little spiffy you can do if you want to practice. Let's go back to our activity now. Okay. Now, what I'd like you to do is think about, again, remember that positive linear correlation, as one goes up, the other one goes up in a line pattern. Negative linear correlation, as one goes up, the other one goes down in a line pattern. I want you to take a minute and think of a real-life example of two quantitative variables that have a positive linear correlation, and then write it down, and then two variables that have a negative linear correlation and write it down. So we'll pause while you do that, and there are lots of right examples. Let's talk some more about our correlation and then do a hypothesis test. So here's some data from Utah. So we have several different counties in Utah, and I researched the number of people in the county and the number of crimes that were committed in the county for a given year. Okay, and I have a selection of, looks like 8 counties here in Utah. So let's make a scatter plot of our data. Let's do that together. And the first thing we need to do is decide which data is the X data and which data is the Y data. And the Y data typically is the dependent data. It is more likely to depend on the X data. So it makes more sense that the number of crimes committed would depend on the number of people in the county than the number of people in the county depending on the number of crimes. So we're going to put X here by the number of people and Y by the number of crimes. And I'm going to slide this up so we have a little bit more room here. So on the x-axis, we notice that our smallest value is 7.3 and our largest value is 61.6. And notice that these are the number of people measured in thousands. So this is close enough to 0 that we could start at 0, and that's, I don't know, we might start at 0 and go up to 70 by tens. So let's do that. Try to make it about as even as you can. I know it's not going to be perfect. Mine's not perfect either. Okay. And so this is the number of people in the county. And even though Utah is a small state, this is measured in thousands. Okay. And the number of crimes, again, the lowest was 76 and the highest, Tooele County, was 1707. We could maybe go up by 200 or 250, starting at 0. So let's do, yeah, let's do 500, 1,000, 1,500, and 2,000. And as always, we need to label things. So on the axis here, this is the number of crimes committed in the county. And now we're going to plot our points. So for Box Elder County, the x-coordinate is 51.5 and the y-coordinate is 1,153. So let's come over here to 51.5 and come up to where 1,153 would be, and we'll put a point. So I'm going to pause the video and then we'll pick up in the next one. So make sure that you finish this scatter plot. We'll compare notes in the next video.